My hockey net looks as such, yes? This distance is 1 meter deep. Agreed? This distance across here, it doesn't matter which one you're going to use because it's multiplying, yeah? So we're going to make this 1.83, which makes this 1.22. Is everybody happy?
Yes.
Okay. Now, I'm going to fill this net with pucks, yes? As soon as I say fill, what do you automatically do without thinking? You say volume, yes?
Yeah.
I say fill, you say volume.
Volume.
Okay, just like if we were rap stars.
What?
Never mind. Except, what shape is a puck?
Circle.
They are cylinders. So, can cylinders fill up a rectangular space?
No.
Why not?
There's empty space.
They leave empty space because cylinders are circles, yes? So, how many pucks could I fit across here? It's 183, or it's 1.83 meters, and pucks have that diameter. How do I tell how many can get across here?
You would first convert
1.83 meters equals what? 183 centimeters. How many pucks will fit across there? What math do I do? Plus, it's 183 centimeters across. The pucks are 7.62 centimeters. Divide by 7.62. And that gets me an answer of what? Do the math. You have the calculator. Do the math.
Wait, don't say it. 24.01.
How can I put a 0.01 of a puck?
24.
24 pucks will fit across. Agreed?
Yeah.
So, I got 24 pucks, and I'm drawing them in black. Agreed? How many pucks will fit up and down? 122 divided by what?
7.62.
No.
Oh, 2.4.
2.54. How many pucks will fit up and down?
48, and you don't add that.
48. So how many pucks would it take to fill up the front of this goal? 24 times 48, which is how much? 1,552. Agreed?
Yes.
So this whole rectangle in front would take 1,552 pucks. How deep is it?
1,152. Sorry.
1,152. It is 100 centimeters deep, divided by what? For how many pucks I can go backwards? 7.62, because a puck is a cylinder, so its radius is the same in every direction. How many pucks back can I go? I know you keep on saying one, and I don't know why.
7.62.
100. This is where math teachers get confuzzled. You knew what to do there. Then you repeated the same math there with a different number. So what do you do here? Divide. And what is the answer? 13. So this 1,152 pucks that are at the front of the net goes back how many times?
13.
So what do I do with that number?
Multiply by 13.
Multiply by 13 to get what?
14,976.
14,976. You all wanted to do volume because you heard the word fill, right? Good thing my name isn't Phil. That would be funny. Because every time you hear Phil, you would do volume. And I'm a loud dude. But my name's not Phil, so it doesn't matter. See what I mean, ladies and gentlemen? It is not about formulas. You have to think. Number 3. course I'm going to give you time. Nathan. With which one?
Number 1.
Number which?
Number 1.
Okay. Everybody else is working on number 3. And number 3, of course, has 2 parts. Make sure you do B. Let's talk about cans of soup. Just A. Because once you know A, you can do B. No. The paper can only go on the rectangle, yes?
Yeah.
Does it go inside or outside?
Outside.
So it's surface area of a cylinder, which is 2 pi r squared plus 2 pi r h. The 2 pi r squared is the circles. Is any paper going on the circles?
No.
So do I even bother with this? No. It is 2 pi r h for 1 can, right? So what is that? 2 pi, what's r?
It's
4.25. What's height? 12. So that is 2 times that is 8.5. 8.5 times 12 is 102 pi, correct? For 1 can. How many cans does a factory make in a day?
100,000.
So what do I do with that number?
100,000 times.
I multiply by 100,000, which means I need 5 zeros. 102 and 1, 2, 3, 4, 5 zeros. Pi.
So we
Now, is that a real life number? No. I'm just going to wait till they finish in the back because it's so rude to interrupt people. I was just waiting until you were done, Malik, because I don't like to interrupt. What with, teaching in a class in school and all. Oh, you done? So you don't mind if I continue?
You may.
Thank you very much. Good job, Sage. By the way, you 4, keep it up.
Thank you.
So, pi. Is that a real life number? Of course not. That doesn't tell us anything. So you should do this multiplication to find out how many centimeters cubed I will do in a day. Yes? So you do that number and you get an insanely large number.
32 million.
Right? 102, it is 10,200,000 times about 3, right? So I'm happy to say, who cares, 31 million centimeters squared, yes? Now, would we measure our classroom in centimeters?
No.
That would be idiotic. What would we measure our classroom in? Meters. So this is not any help to us. But we know that 1 meter equals 100 centimeters. We know that 1 squared meter equals 100 squared centimeters. Yes? So here I have centimeters squared. So I must need that 31 million to be converted to meters squared over centimeters squared. Well, the meter squared got a 1. The centimeter squared got 100 squared. What is 100 squared? If you don't know, go to your calculator. But you should be able to do 100 times 100 because you know how to do 10 times 10. So what is it? 10,000. So I'm dividing by 10,000 here. Now, how many zeros do you see? How many zeros come off the top now? 4. And I'm left with 3,100 meters squared. Does everybody understand how I got there? I have drawn it 1,000,000 times. If you still don't get it, you need to either pay attention when I draw it for the 1,000,000th and first time, or learn that every dimension needs to be converted. Since I'm doing area, I must convert in both length and width. So I have to convert by 100 twice. Okay? Nathan.
Why couldn't you just I know I did this wrong, but I was just thinking this way, like, since you only need the rectangle that would make up the cylinder, right?
Yep.
Why couldn't you just do length times width?
Because the length and the width of this is 2 pi r, because it's the circumference. So, now, could you have made your life easier by converting these to meters right away?
Yeah.
Could I have made this 0.12 of a meter and 0.085 of a meter and then done all of this that way? Yes, you could have. But that's the type of thing that you guys are supposed to figure out. Right? Heather, you had your hand up right there.
What do we do over the 1 meter squared? What is that underside that you wrote?
100 squared centimeters. You got to square.
Squared it again.
Well, no. Centimeters squared is the unit. The number would be 100 squared.
Why did you square the unit again?
Because area is always measured in square centimeters. Okay, this seems to be an issue with more than one person. And we are running out of time, so I'm going to spend just a moment on this. 1 centimeter by 1 centimeter. This is 1 centimeter squared. How did you get that? You took 1 and you squared it. The number isn't the unit. So if I have 10 by 50, this is 500 centimeters squared. But never did I square either of those numbers. Okay? All right. Once again, you will work on B. You will try page 41. And 42 and 43 are things I would like to go over because they lead us right into trigonometry. You can try them. Yes.
For the cyclist one, as you can see, I got the meters into 1.32.
So, all right. So that's the.
How many times I would do in meters and centimeters, meters.
But
So just my other is my back pocket and I sit on a rock and the screen crashes. That's loud.
but that isn't correct. What measurement are you seeking there, Sasha?
Meters and
No,
centimeters.
no. Those are units. What measurement are you seeking in that question? How far will the bike travel? What measurement on the bike of that wheel will tell me how far it will roll? The diameter is how far something rolls. There's the wheel. This is the top of it. When the wheel rolls, how far did it travel?
Height.
The height does it. Dude. It rolls. How far did it travel? What part of that circle showed me how far it traveled? The circumference. So I need the circumference of that front wheel. Circumference equals what? Put your chairs up! You're the worst class in the world for it! And I mean this because I have 3 classes. You guys are the only class that don't do it. Except Rylan, who hates chairs so much he just beats them up. Remind me, Rylan, I will tell that story one day. So, how do you find a circumference? It's on your formula sheet, if you don't remember how. Once you know that circumference, you then know how far the wheel will travel. It totally is okay, Rylan. Think how many times these chairs are sat on. And think how many times they're abused. Every time I look back, I see kids leaning back in them, throwing them around. Yeah. I'll make another one. Do you need it now?
Not really.
Okay.
Thank you.
No problem.
Bye, Mr. Meyer.
Goodbye.